So yeah, there's this question from JAM 2007 that says, what is the volume of oxygen required to burn completely 45 centimeter cube of methane at STP? Methane at STP. So to solve this question, it's a stoichiometric question, meaning calculations from a balanced chemical equation. So it means we have to construct an equation that shows the burning of methane in oxygen. So right now we know we are dealing with the hydrocarbon methane. So if it is methane, it means an alkane. An alkane, they contain only carbon and hydrogen since they are hydrocarbons, and the number of hydrogen is always double the number of carbon plus an extra 2. So if we say methane has just 1 carbon. So if we double the number of carbon, we get two hydrogens plus an extra 2, which will be 4. So the formula of methane is CH4. So we have to burn it in oxygen. So if you burn it in oxygen, you have this. Then what it will give you, when hydrocarbons are burned in oxygen, excess oxygen, they give, or they are completely burned in oxygen, the product is carbon 4 oxide, which is CO2 plus water vapor. So we've constructed an equation. Anytime a hydrocarbon is burned in oxygen, it gives us CO2 and H2O. But then we still need to balance this equation. So we check carbon is 1, carbon is 1. Hydrogen right here is 4, but here it is 2. So I put a 2 here. So 2 times 2 makes this hydrogen 4, so it's complete. So let's count the number of hydrogen at the right-hand side. This is 2, sorry, oxygen rather. This is 2, and this is 2 times 1, which is 2. So 2 plus 2, 4. But there are just 2 oxygens here. So I make it 2. Now, there are different ways to solve this question, but I'll use a method that solves it so fast. So the question says again, what volume of oxygen? So right here, we are looking for the volume of oxygen required to burn 45 centimeter cube of methane. So the idea is that the question is between methane and oxygen. Nothing concerns CO2 and nothing concerns water. So we're looking at just methane to oxygen. So the next thing we ask ourselves is, from the equation, what is the ratio of combination? The ratio of combination is 1 mole of methane ratio 2 moles of oxygen. What this simply means is, for anything methane uses for this equation, for this reaction, oxygen must use a double, that's times 2 of it. So if methane is using 45 centimeter cube, that's if we need to burn 45 centimeter cube of methane, we need double that amount of oxygen because the ratio is 1:2. Hence, the amount of oxygen needed will be 45 centimeter cube times this 2 right here. So 2, which gives us 90 centimeter cube. Therefore, the volume of oxygen required to burn completely 45 centimeter cube of methane is 90 cm cube. I hope that does it. And that is option D here. Thank you.